Hey guys, and welcome back. So now we're going to continue with the wood setup, and I have the geo here, and let's scale it up 20 units, and this is our fractured geo, this OpenGL issue. Okay, so that's our geo. I'm not going to use the entire block. I'm just going to use one of them. So let's disable this. And I'm gonna paste the fracturing that we made in the previous video into this file. So I'm gonna scale it after. Okay. I'm going to reduce the number of pieces to 20, so we have something lighter to work with. Okay, I think that's a good start, and I'm going to move it to the center so it interacts more with Kong. Okay. Now for the constraints, let's first assemble it and name it. So we'll call this wood. And for the constraints, we're going to use something called cone pin constraint. And this basically, this is similar to the pin constraint, but it has a specific, it doesn't allow the pieces to rotate more than a specific angle. It has resistance, and this is going to help with the overall bend, giving this the bendy look that we generally see in wood. So to get the proper deformation in these splinters, we're going to use the cone twist constraint, which limits the movement of the pieces. So let's connect them. Okay. That's good. And then I'm going to create a wrangle node, and let's copy some stuff here. And let's actually copy all this. So for the name, I'm gonna call it cone, and we're gonna convert them into points. Cool. And I'm gonna call this out wood CST. And then we're gonna pack this. And this is going to be wood RBD. This is our sim. I'm gonna copy that. Let me delete this. Gonna copy this so we have a backup. I'm gonna call this sim wood, and let's dive inside. I'm not gonna connect these guys for now. I don't need this, and I don't need this, so I'm gonna create a packed RBD object, and we'll use Kong. I'm going to call this wood. Okay, let's copy the path. And I'm going to create a new constraint network. And I'm going to create a cone twist constraint. And you see here we have a lot of new options. We're going to leave all these guys to the default, and this is where we can specify the max rotation. So we'll set this to 60 and 60. And then let's see what else. We need the constraints, of course. And we need to set the name to cone. Okay, let's take a look. Awesome. Everything seems to be working. Let's hide this. And I'm going to move the structure temporarily so it doesn't collide with Kong from the first frame. And let's template this guy. Something like this. I'm going to set up a few things. I'm going to set up the active attribute. I don't want everything to be active, so I at active equal 1, and then if the position of the piece is b at p dot y is less than, say, 5, I want the active to be 0. And let's isolate and see. Point attribute, okay. Maybe we can make it higher. 10. No, it's at 5. We'll increase the number of pieces. Right now it's quite low, so I can get something interactive. Okay. Let's go back. I'm gonna lower this to 10 and 10. And let's hit play. And it's exploding. The reason for that is the cone twist has a rest length of 1. We need that set to 0. And it should resist and bend and deform, and right now it's not breaking at all. So let's set up the braking system. I'm gonna use a SOP solver, and I should have pinned the viewport. So let me play 2 frames. Okay, and I'm gonna go to geometry and pin this. Okay, I'm gonna pause and we'll continue. Okay, let's import the constraint object merge, and then let's go to relationship and constraint 2, constraint network, and let's drag the geometry. Okay, and let's see what this guy has. So let's go back to the main viewer and let's play a couple of frames. And let's dive inside. Okay, so we have our constraint, and we have an angle attribute, we have a force attribute, we have a torque attribute. So what I prefer to use is the torque attribute, which gives a very nice result with this. So I'm going to say point primitive if the torque is higher than, let's start with, seems a bit high, let's start with 50,000. We're going to change the name to cone broken. Okay, let's go back and let's hit play. Doesn't look like it's breaking. Let's see. The condition didn't work. So this is correct. Okay, I'm gonna lower the value and do one more test. Let's say 2000. Okay, let's hit play. Still doesn't, it's not breaking. Okay. Is this, yeah, it is breaking. Let's set it even lower. And let's change the wood property to, I'm gonna give it a mass of 1000. Let's hit play. Okay, I think we have a lot of pieces that may be, we have very long shards. That may be causing some of this issue, but I would definitely expect it to break. Let me go to this frame. Okay, let's try angle. So this is a primitive attribute. Yeah, everything is. Let's try angle. And if it's higher than 0.25, S constraint name. Yeah. Everything looks good, so let's continue. Yeah, the pieces are not breaking for some reason. Okay. So I'm gonna do one more test. I'm gonna go up and increase the number of pieces, and if this doesn't solve the issue, I'm gonna pause and we'll do some investigation and figure out what's happening. So this is correct. Okay, let me delete some attribute here, some leftover attributes. I don't need the up, I don't need this X. And this is all primitive. And let me delete the groups as well. Okay. So I don't see any issues with this. I'm gonna lower it even more. And let's do one more test, see what we get. Yeah, something is definitely not right. But what I wanted to show, I mean, this is a good test. What I wanted to show is this flexing behavior. And this is something we can get easily, as you can see with the cone twist. Now let me figure out why the hell it's not breaking. This is really strange. So I'll do some investigation, and I'm going to we'll continue in the next video. I'll probably have to increase the number of pieces, but overall this is the part that I'm interested in, this kind of flexing. Cool. See you in the next video. Bye bye.